Okay, so this is video 7, doing sprites and the visualizer, as well as the image manager. So for the sprites, game object 2D, they have a set angle, scale, position, center, as well as a render and update function. So all the matrices associated with those, as well as the rectangle for the image, the graphics object sprite, and the final world matrix. So I guess I should also just quickly mention, there's a game object 2D default constructor, as well as one that takes in an image. Actually, never mind that, I took out what I was going to do. The default constructor doesn't do much. So just the specialized constructor here uses the rectangle, creates a rectangle from the image, creates the graphics object for the sprite using the model manager and the shader manager for the for the model and the shader. It also uses the image that's passed in and creates the world transform from that. It also just has the sets for angle, scale, position, center, and then render and update. So that is what's in there. Let's see. Let's see. I didn't end up putting in the flyweight pattern. Just didn't quite have time. I think I showed the constructor. I need to show the image manager. It has a load image. It has two different types of load images. It has one that's just a string and a texture, and that will build a rectangle of the whole image. A rectangle for the image of the whole texture. This constructor here will take a small portion of the whole texture to create the image. Other than that, it has the unload images for deleting everything, a specific get image, and a terminate function. And then this one is set up as the singleton. So that is that. For the CPP, it's once again using my crazy hash table, using these node objects. But anyways, these just calls the private version, which I'll get to in a second. And then this is the specialized constructor, running it through the hash table and storing it there. The unload images, the get image, the terminate, and the destructor. Let's see. So this is the private part. The same thing as the one up top, just using the entire texture for creating the rectangle. The private version of the unload images, as well as get image, and the terminate, which just basically deletes the table after each object in the table has been deleted. So that's the image manager. Next up was the visualizer, which has a default color. It will create the just a basic wireframe constant color graphics object using the B sphere. It also has the destructor, of course, which deletes it. It's set up as the singleton and just has a default color. It also has some of the public methods for showing the B-sphere, visualizing all of the visualizer objects, and then of course setting the color for a specific visualizer. I already know you've seen it all in the past, but here's the visualizer in action with the ability to switch colors once it runs into things, so that's all good. Let me just make sure. Yeah, so for the CPP, it's just running through everything, the private render, the submit render for creating them. It uses something similar to a command pattern. It's just all withheld within the visualizer class. So it pushes. So when you call submit render bsphere, it's actually pushing it onto a list of the bspheres, and then at the end of the very end of the frame, well, not the very end, close to the end of the frame before sprites are drawn, it draws all of the bspheres at the same time. So it has delayed. It has the delayed effect of the command pattern without actually passing anything through the broker. So I think that is acceptable. If there's not, I'm sure I'll hear about it. But anyways, that's what I have working for right now. So the it has a show bsphere function, which just sets up the world transform and then calls the submit bsphere function, which then goes up here and actually does that. Then like I said, the visualize all function basically just goes through the list and renders all of the visualizers within the list, and then on that frame clears it out. So it's not wasting a ridiculous amount of memory because we're creating new ones. So there's no memory being lost there. And then of course the set color function. So I do believe that is all for those. Should be good to go. Cool, thanks.